All right, we're going to finish up these notes. I just want to get them done. Also, do one problem from here. This was not given to you guys last week, and I should have, but I didn't. So it's kind of lingering out there. I want to make sure that you guys can graph parabolas. So we're that's a little weak right now because we just, I don't know, I feel like we ran out of time during one of the class periods or something. Anyways, what I thought I would do then is we're going to do 9, 10, 11. I'm going to do those quickly. But let's go back to this. This is a homework that will be passed out to you. These are not technically notes. We already kind of took notes on these, but I think there were a couple examples that we didn't complete on this one. So let's do this one together, and it'll actually just give you 4 graphs to do, and then this multiple choice. And so just remember when you do the graphs that you label each one of these, because if you do this, things like this will make a lot more sense for 10 and 11. Okay, so that's why I'm taking the time to make. So in order, work on this first, get that done, talk to the people around you, make sure that they're getting the same thing, because then that means you guys are probably all right, because you guys are like that. And then these 3 we'll do. Okay, so let's do this guy first. And number 2 is going to be a parabola because, first of all, only one of the variables is squared. And second of all, you'll notice that there's 2 things on both sides. The x is on one side, the y is on the other. Okay, so that should tell you it's a parabola immediately. This is not a typical form that we are used to. This is transformational form. We're used to like things, quadratics equaling 0, right? Or ellipses and hyperbole equaling 1. So these guys kind of equal each other in a way. So what this means then is because the y is squared, I got 2 options. It means that I'm only going to have 1 curve, not 2 like a hyperbola. I'm going to have it either go this way or I'm going to have it go this way, but only one of them. Now because this right here, the number in front of the non-squared variable is negative, then I know that it's got to be this one. Okay, if there was no negative sign there, then it would be this guy. Okay, he would be going to the right. So he's going to go this direction. Okay, now, so where though? So what you do is you just use the same analysis that you would use for others. You just look at this guy that tells me -6. This tells me +5. So -6, +5 is all the way up here. Okay. Now I don't have much room, but I am going to shoot off this way. Okay. The question is like how far. Now I'm going to use a pencil just so I can get in a little closer here. Okay. These guys are graphed a little weird. Okay, these are built for more physics problems. Okay, and so basically this is kind of preparation if you want to go into a field that requires some kind of engineering using optics and stuff like that. But anyway, now that we've got that, looks like that's all we got. We know it goes this direction. In fact, you could probably get away with graphing this guy just by going like this if it was the SAT. But to be technically correct, what we want to do is we want to treat this guy as a value that equals 4p. Okay. Now the p value is very similar to the c value of the ellipses and the hyperbola. So I'm going to solve for p, and I'm going to get -1/4. Now the negative sign is already taken care of. I know I'm going this direction. The negative tells me this. But 1/4 tells me that my focus is now going to be on the inside of my curve only 1/4 of a unit. So he's going to be very, very, very close. Okay, he's going to be right there. Let me zoom in a little bit. All right, so he's going to be right there. So this means that my focus is actually this point. He is not, now his y-coordinate is actually +5. Okay, but he is not -6. He's actually -6 1/4. Okay. Now I don't care if you write that decimal. You could just put -6.25. In fact, when we do these other problems, I would recommend that we just do decimal. We'll convert it to decimal because we want to graph it anyway. So, anyways, that's my focus. Now the directrix is directly behind this guy, 1/4 going the other direction. Okay, so he's nice and snug right there. And what I want to do is I want to double this quarter this direction, which would give me a half. 1/4 times 2 is 1/2. So a half unit there and a half unit there. Okay, and that is all that I have to graph this. That's it. 3 points. Okay, 3 points. This guy looks something like this. Okay, so this means that my directrix, okay, and that's really the focus on the directrix that constructs these parabolas, but the directrix is a line, okay? Now he's not the graph of the equation, okay, but he assisted building it. You'll notice that he is a vertical line in this situation, so it would be x equals. Now, if I'm going a quarter on the other side of -6, what that really is -5.75. He's a quarter of the unit the other direction, okay? And that's just fine, just like that. You'll notice, too, that the axis of symmetry. The axis of symmetry is what this guy is, cut straight down the middle. And you'll notice the axis of symmetry is going to be the other variable. It will not be an x equals. It will be a y equals, okay? Because he is perpendicular to the directrix, okay? So this guy is actually 5, so he is y equals 5, okay? And we already knew that the vertex was -6, +5, okay? So you want to be able to label all 4 of these things for a parabola, okay? And the graph is also the 5th thing that you want to be able to cover, okay? Where are we at? We're at 6 minutes. Okay, so we'll do this one, and then that actually, yeah, I think 10, 11, you guys can pretty much judge it. But let's do this one, just because it's a perimeter of a central rectangle. I can't remember if we did this or not. I'm going to try to be quick, but not too quick. Now, first of all, put this on graph paper because I need to draw a picture. Some of you might not need to because you're just built differently. But I do know that these vertices, I don't like seeing those as fractions because if I'm going to graph them, I want this to be kind of, I want a decimal, like 17/2. I'm going to convert it into my brain as a decimal anyway. So that the vertices, that actually is, well, let's see, 18 would be 9, so 17 would be 8.5. Okay, so 8.5, 8.5. And then the other one is 2.5 and 8.5. Okay, now I'm going to use this information to figure out what this is a hyperbola, by the way. Okay, we're in the hyperbola section. So what I'm going to do is I'm going to draw this guy, 8.5, 8.5. Oh, he's kind of high, so we're going to go like this. Okay, so 8.5. Let's go 1, 2, 3, 4, 5, 6, 7, 8.5. And then shoot, lost track. 1, 2, 3, 4, 4. Okay, so that's 9. There's 8. 1, 2, 3, 4, 5, 6, 7, 8.5. There's 9. There's 8. Okay, so half. Then we got 2.5. 2.5. There's 2 and there's 3. So we're going to go ahead and put this guy here for this one, and then this guy will be right here. Okay, now because this is a hyperbola, okay, I already know that this guy is going to go like this and like this, okay? But what I need to do is figure out the size of the central rectangle. Now, they said that the central rectangle is actually 48, okay? Right here, that's given information. That's the perimeter. Okay, so this means then, okay, that I know, now I don't know how high or how low this thing goes, okay? I just know that the perimeter of this central rectangle is 48. So I do know that this distance, though, is given. Okay, now I'm drawing a dotted box because I don't know how tall it is. But I do know that this distance from 2.5 to 8.5 is 6. Okay, now that distance is 6, so this means this guy has to be 6. Okay, obviously it's a rectangle. So if 48, this is our y coordinate now, that means that if I add 6 plus 6, both the y's plus 12 have to equal 48. So I'm going to go ahead and go to y. I'm going to subtract 12 from both sides. What is that? 36. Okay, so then that means divide by 2, and I get y equals 18. Okay, so this means this guy goes, this is a distance of 18. Okay, 18 plus 18, 6 plus 6, that is equals 48. So that's how we're going to use this information. So this means that the equation of this guy is now pretty much done. You've got, you know it has to equal 1. You know that you're going to have two fractions. You know this guy goes this way, so x has to go first. Okay, there's minus in between. Okay, and we know that our vertex is 8.5, so let's go minus 8.5, minus 8.5. No, the center is here. No, it's not. My bad. It's in the middle of the vertices. Let's try that again. I don't know why I put a 1 there. Choking. Well, yeah, 11 minutes. Okay, so right in the middle between 2.5 and 8.5 is 6 units. So if I went 6 units all the way, that means if I go halfway, 3 units this way, okay, that's going to be 4, 5.5. That's 5.5, okay? But I am still 8.5 high, okay? I'm still 8.5 high. It's just that I'm 6.5 on my x, okay? So that's 8.5. I'm up 8.5. I'm over 6.5. I had to cut that in half. Okay, so what's next? I got to figure out if this distance right here on my x's is actually 3. That means that I should put a 9 right here. And if this right here, from here to here, okay, that is half of the 18, this must be 9, and that must be 9. So I'm not going to put 18 here. I'm going to put 81. All right, now that's it. That's all you needed, because I believe that's all you need to write the standard form of the parabola. Okay, so this basically is kind of showing that you absolutely understand all of the mechanics related to a hyperbola. We didn't need the focus in any way, okay, but that's just fine. Okay, so finish up these guys. Go ahead and give. I think there's only 2 questions in your homework with this. Give this a shot based on what we did with this guy. Okay, I don't think I need to make the video longer to do 10 and 11. Okay, should cover it for today, and I'll see you guys tomorrow with a practice test.